Hi students, and welcome to HSC Chemistry and experiment 4, constructing a galvanic cell. In this particular experiment we're going to be looking at some of the features that are important in the construction of a galvanic cell. So we're going to look at the effect of the electrodes and also the electrolyte on the voltage or the amount of potential difference that is produced in a particular combination. There is a second experiment, experiment 5, in which you will be looking at some of the different combinations that are put together to produce a galvanic cell. But in this particular experiment, you just have to look at some of the factors that are important in its construction. Following this particular slide are a couple of other slides that give you just a little bit of an overview of what exactly happened during the experiment. Some of the audio is a little poor in quality, so that is something that we may look at a later date. But I thought I'll give you a bit of an introduction now. You can have at least a look at what's going on, even if you can't hear it all. We'll do a little bit of a summary and then we'll finish it off. So that you can see we've got a solution. Actually, in this case, it's just distilled water. I also have two electrodes. I have a zinc electrode here, which I'm just going to dry a little bit and also just clean up a little too. It's important that you make sure that you keep your electrodes nice and clean, because that is going to affect your results. And I have another one over here, make sure it's dry as well, and it's copper. You can see the copper colour, possibly you can see the copper colour there. It's a little discoloured, so again I'm going to give it just a quick rub with the emery paper to see if I can remove some of the deposits. Our electrodes are used quite often, so don't always know what state they're in. We want to make sure that we get good connections. The connections, of course, need to be solid all the way through this little circuit. I'm trying to complete a circuit here, and that's one of the keys to our galvanic cells. We're going to look at the application of galvanic cells as producers of electrical energy and how they relate to some of the batteries that we use as well. But we'll do that in later videos. For now, we just want to see if we can look at some of the different features of a galvanic cell and what sort of things we need in order to try and get them to perform optimally. So what I'm going to do is I'm going to drop in the zinc and then the copper. So zinc electrode and copper electrode, and when I complete the circuit, I can see I have a very small reading there. I've got plugged into the 2 volt, I'm not sure if I can leave these here without them touching, but I have there a reading on my voltmeter. That is somewhere in the vicinity of about 0.2 of a volt. So not very much voltage there, but you can see that I should move that aside a little so that you can kind of see a little bit better what's happening with the voltmeter. But the reading is actually occurring when the 2 electrodes are both placed in the solution. Now, as far as our electrochemical cell goes, though, 0.2 volts is not very much of a reading. So what are some of the other things that we can do in order to try and improve that reading? So the key to this particular experiment is we want to identify some of the factors associated with construction of a galvanic cell. So the important things that we need to be aware of is firstly that we have to have a complete circuit. If we don't have a complete circuit, then the current will not flow. So this can include things like the external wires, a salt bridge if one is present, good conducting electrodes, and also the electrolyte. We need to make sure that we have standard solutions, which are 1 molar solutions, or 1 mole per litre. solutions of our electrolytes. We also need to make sure that we have clean and dry electrodes for both our anode and our cathode. Now, sometimes the electrodes will participate in the reaction, and other times they will simply help facilitate the transfer of electrons. We need to also make sure that we have good electrical connection. And also things like we need to use different electrodes. I'll put different metal electrodes in combinations. And we will explore this a little bit more in one of the future videos. Combinations. So what you'll see coming up in the next slide is again another part of the experiment which just replaced the electrolyte. We looked at water, we looked at sodium chloride solution and also at sulfuric acid solution, and then we replaced the electrodes as well. So we looked at a combination of zinc and copper, copper with copper, and also carbon with copper. So I'll give you an opportunity to have a look at some of that. Again, apologies for the audio. Well, the first thing we can do is we can replace the liquid. So the liquid that I just used was distilled water. So distilled water assumes there's no ions. The fact that we've actually got a reading suggests that maybe that beaker wasn't as clean as it could have been, and there might be a few little ions moving in there to close the circuit. But I also have some sodium chloride solution. So I'm going to swing that in, and when I try the sodium chloride solution, you can see that, maybe you can't, the reading on the voltmeter has gone up quite considerably. Okay. The reading on the voltmeter has now gone up to about 0.85 of that. So the reading is much higher than what it was before. And this is because I haven't changed either of their two electrodes, but the electrolyte now is much more effective. The sodium chloride in there is conducting the ions between the two electrodes, closing that circuit much more effectively. And so now I have a much more efficient circuit, and it's giving me a much better reading. Now what happens if I replace both of those with sulfuric acid? Again, let's just give these a bit of a clean. Just before we go on. So sulfuric acid is an electrolyte that's used in lead acid batteries. And we'll see if it gives us much of a reading. Okay, well the reading is higher, but there's a couple of things to notice. Now I've got a reading of 1 volt, but I've also got a lot of things happening. Actually, you can see on one of these electrodes there's a huge number of bubbles that are occurring. So in actual fact, I've got a different reaction happening here. You can see how quickly that colour has decolorized, that water has decolorized, the solution has decolorized. It's the hydrogen ions in the sulfuric acid that are actually being displaced by the more reactive zinc. So because when the hydrogen is displaced from the solution, it produces hydrogen gas. That's where all those bubbles are coming from. It is a reaction which is enabling electrons to move, and so therefore I'm completing the circuit, but I'm using a slightly different combination of chemicals this time for my galvanic cell. So if I keep the sulfuric acid, which seems to be the best one, and replace my zinc electrode, which is doing all the bubbling, with another copper electrode, what happens then? So what do you think would happen if I had 2 copper electrodes, both sitting in this sulfuric acid, which is a little decolorized now? I might just replace that. So it's a little bit easier to see. Some sulfuric acid. And just put that in. And this time I'm going to use the, I'm going to have both of the electrodes being copper. See if that makes any difference to my voltage. Remember, it was about 1 volt the previous time. That one's still damp, so we'll just dry that and give it a bit of a clean. See what happens this time. Okay, it's actually giving me a slightly negative reading at the moment, but nothing much is happening. Certainly not what was happening when I used the zinc. So this could be a bit of a problem, or it could be telling us something about what happens in a galvanic cell. In this case, the two metals are identical. They're both copper, and so nothing much is happening as a result of putting both of those metals into the same solution. So having a different metal obviously seems to be one of the key things that I need. But the problem with the zinc was bubbling away and interacting by displacing the hydrogen in solution. So what if I use something that is inert, like carbon, a graphite electrode, which again I've dried and given a bit of a quick rub. So let's see what happens with this one. Oop. It's fallen back negative, so let's just switch these over. Okay, now again I've got a value. Not as high as it was before. Oops, I'm just losing it a little bit. One more hand here. So it's about 0.3 volts. Not as high as it was when I used the zinc electrode, but still something is happening in the solution. So there's a couple of important things to be aware of here when we're looking at the conditions under which a galvanic cell is produced. The first and the most important thing is that our electrodes must be of different metals, must be of different substances. Sometimes the solution itself will be participating in the reaction, and other times it will simply be acting as an electrolyte, allowing the passage of ions to move from one electrode to the other in order to complete the circuit. A couple of other things that are important is the concentration of the solution or the electrolyte that allows us to have free ions available to move through the circuit, and a reasonable difference in the activity of the two electrodes in order that they may be that we may be able to see a difference. Of course, we know that the carbon, the graphite, is going to be an inert electrode, so that's not participated in the reaction. In fact, what's happened is, again, we've got a reaction between the hydrogen ions and the copper. Not a big one, but enough for us to generate a small amount of electricity. This just gives you a little bit of an idea of some of the conditions under which galvanic cells operate, and we'll look at how we can connect a few different types of galvanic cells and calculate their cell voltages in the next. So some of the important things just to have a look at then, quickly reviewing the key factors that are part of optimum function of your galvanic cell is clean and dry electrodes, standard conditions of 25 degrees and 101 kilopascals. Now the 25 degrees is pretty much the important one here, because depending on the season, the time of the day, it can be a temperature other than 25 degrees in the laboratory, and this can affect your results. Standard solutions and also electrolytes should be 1 molar solutions with plenty of ions in there to help conduct the circuit and ensure that the ions that are present will not form precipitates. We have a flow of electrons from anode to cathode through the external circuit, and then internally the ions will complete that circuit. And one final thing just to point out is that all of the values that we're going to measure for our galvanic cells are comparisons, so we need a reference in order to do that. So the reference one we use is hydrogen. So hydrogen ions will take in electrons to form hydrogen gas, and when they do that, our E0 value is 0 volts. So that's why we call this our reference cell. Obviously what we have to do, we can't have something happening on its own, so we have to have an oxidation and a reduction occurring. Those electrons have to come from somewhere. And so this is our reference. So we use this just as our 0 point. We could just as easily have picked a different
half cell in order for this to be our reference point, and all that would do is change the relative numbers, positive, negative, up, down by the same amount as whatever we chose. So this hydrogen is the reference point from which we use to compare all of the other values. So hopefully this gives you a bit of an idea about how we set up a galvanic cell, the basic conditions required, and we'll look at the different combinations of metals and the voltages that are produced in the next video. Thanks for watching.